Hey, hi everyone. Once again, welcome to Mathematics Mania YouTube channel. So in my previous video, we saw the nth derivative of few of the important functions and a few of the numericals. And in this video, we will again see few more numericals, starting with the first question here. So if y is equal to x square divided by x minus 1 the whole square into x plus 2, so we need to find the nth derivative of this function y. So again, this function we will not be able to find the nth derivative directly, so we may have to write this fraction y is equal to x square divided by x minus 1 the whole square into x plus 2 in the form of a partial fraction. So once we get the partial fraction and find the coefficient a, b, c, then it will be easy for us to put them in the form of 1 over ax plus b, and then we will be able to find the nth derivative of it. So so let's write this fraction x square divided by x minus 1 the whole square into x plus 2 as a divided by x minus 1 plus b divided by x minus 1 the whole square plus c divided by x plus 2. So so here this is how we may need to write the partial fractions here. So when we have two terms, one with x minus 1 and another one with x minus 1 the whole square, so we will have to write it two times, that is a divided by x minus 1 into b divided by x minus 1 the whole square, and x plus 2 is there separately a factor that will be written. So if anyone wants to know a detailed way of writing into a partial fraction, given fraction into a partial fraction, so I can make one more video on the partial fraction topic also. But for now let's continue with the derivative. So this is how we can write a given function x square divided by as a divided by x minus 1 into b divided by x minus 1 the whole square plus c divided by x plus 2. So now let's try to find the value of a, b and c. So now let's write it as a square x square is equal to, the LCM of this given fraction will be x minus 1 the whole square into x plus 2. So x square will be equal to a into x minus 1. X minus 1 the whole square is LCM, so 1 x minus 1 will go, so x minus 1 into x plus 2 plus b into x plus 2 here, and plus c into x minus 1 the whole square. Now let's put the value for value of some x, and we will find the coefficient a, b, c. Let's put x is equal to 1. When I put x is equal to 1, this term a and this will become 0 because 1 minus 1 is 0, and c into 1 minus 1 will become 0 again here. So 1 square is equal to 1. So when I put x is equal to 1, 1 square is 1 equal to b into 1 plus 2, that is 3. b into 3, which implies b is equal to 1 by 3. Let me put x is equal to minus 2 here. Why I put minus 2 is because I can make these two terms as 0 now. So minus 2 plus 2 a also will become 0, and minus 2 plus 2 b also will become 0. So what happens here when I put x is equal to minus 2, x square is minus 2 the whole square will become 4, and these two terms will be 0, and c into minus 2 minus 1 the whole square. Minus 2 minus 1 the whole square is nothing but 3 square, that is 9, which implies c is equal to 4 over 9. So if I have to find a, so a x minus 1 is also there and x plus 2 is also there. I will not be able to put, if I put x is equal to 1 also, this time will become 0. If I put x is equal to minus 2 also, this time will become 0, and and I will not be able to find in this way. So what I am doing is, let's equate the coefficients of x square here. If let me take the coefficients of x square. So what will happen, this x square will be equal to, so let's expand this. This will become x square minus x minus 2. So that is x square minus 2x and minus x. So that will become x square minus x plus 2 here, and plus this will become b into x plus 2, and this will be c into x square minus 2x plus 1. So let me just take the coefficient of x square here. So if you see, the x squares are there in the terms this a and c, right? So ax square plus cx square is there here, right? So if we equate the coefficient of x square, so only a and b, a and c as x square terms. This b does not have the coefficient, I mean b does not have the square term here. So what happens, I can write as the coefficient of x square is 1, that will be equal to a plus c. A plus c will be equal to n, which implies what I already have the value of c, so a plus 4 by 9 will be equal to 1, which implies a will be equal to 5 by 9. So now I have got the value for a, b and c. So let me just put back the values here. So x square divided by x minus 1 the whole square into x plus 2 can be written as 5 by n into 1 over x minus 1, right? And b value is 4 by 9, so that is 4 by 9 into 1 divided by x minus 1 the whole square plus c value is b value is 1 by 3 here, right? B value is 1 by 3, so let me write it as 1 by 3. 1 by 3 into 1 over x minus 1 the whole square plus c value is 4 by 9, so that will become 4 by 9 into 1 over x plus 2. So now, so again we have the same old formula, right? That is yn of, that is nth derivative of 1 over ax plus b can be written as minus 1 raised to n into n factorial into a raised to n divided by a plus b raised to n plus 1. So the same thing will be happening here. So it holds good here. So that will be equal to, yeah, so here let's apply the same formula here. So what happens, yn will be equal to 5 by n, nth derivative of 1 over x minus n. So from here it will be plus 1 by 3, nth derivative of 1 by x minus 1 the whole square, plus 4 by n, nth derivative of 1 over x plus 2. So if we observe here the first term and the last term, so we have 1 over x minus 1 and x plus 2. So the power in these two terms are 1, only 1, right? But the middle term, if we see, we have x minus 1 the whole square. So we have 2 here, so that also should be taken here. So what happens, so that would be equal to 5 by n, and nth derivative of 1 over x minus 1 is nothing but minus 1 power n and n factorial. Here the value of a is nothing but 1, x is nothing but 1x, so 1 raised to n is 1 itself, so I am not writing that. So it will be equal to x minus 1 raised to n plus 1 plus 1 by 3. So here in the denominator, if you see x minus 1 the whole square is there, so I mean it is the raised to 2 is there. So what happens, instead of n it will become n plus 1, so that would be minus 1 raised to n factorial will become n plus 1 factorial divided by x minus 1 the raised to n plus 1 plus 1, that will become n plus 2. So plus 4 by n, nth derivative of 1 over x plus 2 will become minus 1 raised to n, n plus so in this will be n factorial divided by x plus 2 raised to n plus 1. So this is the nth derivative of the given function y is equal to x square divided by x minus 1 the whole square into x plus 2. Yeah, so let's move on to the next question. So the next question also is similar to the current question itself. So but in place of numbers, let's have some variables and see. Y is equal to x square divided by x minus a into x minus b. So this is similar to the previous question itself, but here we have x minus a into x plus x minus b. So again here we may have to apply the partial fraction here, because we have again x squared divided by x minus a into x minus b. So let's put this function x squared divided by x minus a into x minus b as, let's write it as a divided by x minus a plus b divided by x minus b. So now what happens, this implies that x square will be equal to a into x minus b plus b into x minus a. Now in order to find the value of a and b, so we may have to put we may have to make one term 0, so that we will be able to calculate the other term. So let's put let's put x is equal to a. When I put x is equal to a, this term will become 0, b term will become 0, because a minus a will become 0. So when I put x is equal to a, x square is equal to a square equal to a into a minus b, implies a is equal to a square divided by a minus b. Same way, put x is equal to b. When I put x is equal to b, so x square is b square will be equal to, this term will become 0 now, so b into x minus a will become b minus a, right? So implies b is equal to b square divided by b minus a. So that is the value of a and b. Now let's back substitute the value here. So our function x square divided by x minus a into x minus b will now become, what is a square divided by a minus b into 1 over x minus a plus, what is b square divided by b minus a into 1 divided by x minus b here. So a square divided by a minus b and b square divided by a minus a are constant, so we need not have to worry on that. Now let's take the nth derivative of this function. So nth derivative of this function yn will be equal to this. Let's put it outside, that is a square divided by a minus b into yn of 1 divided by x minus a plus b square divided by b minus a into, this will become yn of 1 divided by x minus b. So now what happens, the same rule apply here also, a square divided by a minus b. So nth derivative of 1 over x minus a is nothing but minus 1 raised to n into n factorial. Here the value of a is 1, so 1 raised to n will be n, so I am not writing that. So this divided by x minus a raised to this minus a raised to n plus 1 and plus b square divided by b minus a. So the nth derivative of this will become minus 1 raised to n factorial divided by x minus b raised to n plus 1 here. So here what I will do, I will take the in order to take a minus b outside, I will take the minus n outside here, and so what happens, this will become I will take minus 1 raised to n factorial and a by b outside. So what happens here, minus 1 raised to n factorial divided by a minus b. If I am taking a minus b outside, so what will be remaining here, so a square term will remain here, a square divided by x minus a raised to n plus 1. Here b minus a was there, I have taken a minus b, so this term will become minus here, so this will become b square divided by x minus b raised to n plus 1, which is the required nth derivative of the given function. Okay, so let's move on to the next question. So the next question is if y is equal to x log of x minus 1 divided by x plus 1. So that is the function that we may have to show that nth derivative of this given function y will be equal to minus 1 raised to n minus 2 into n minus 2 factorial divided by x minus n divided by x minus 1 raised to n minus x plus 1 divided by x plus 1 raised to n. This is what we may need to show it. So let's start with whatever is given. So we have y is equal to x into log of x minus 1 divided by x plus 1. We know from the logarithmic function that log of a by b can be written as log a minus log b, right? So this function y can be written as, therefore y is equal to x into, this can be written as log of x minus 1 minus log of x plus 1, right? So now our y will become let me take this x to the other side. So y will be equal to x log x minus 1 minus x log x plus 1. So we have simplified our given y, that is x log x minus 1 divided by x plus 1 into y is equal to x log x minus 1 minus x log x plus 1. Now let's start differentiating with respect to x here. Let's take the first order derivative. So y1 will be equal to, let's put the product rule here. First function into the derivative of the second function plus second function into derivative of the first function. So that is x into derivative of log of x minus 1 will become 1 over x minus 1 plus log of x minus 1 into derivative of x is 1, so that is itself, so minus sign is there. So x into log of derivative of log of x plus 1 will become 1 over x plus 1, so plus log of x plus 1 into derivative of x, that is 1. So this is the product rule, that is first function into derivative of the second function divided by, sorry, not divided by, first function derivative of the second function plus second function derivative of the first function. So x minus 1. So let me open, so here this will become log of x minus 1 minus x divided by x plus 1 plus log of x plus 1 here. So here log terms and these algebraic terms, let me move on to the nearest side, that is x divided by x minus 1 minus x divided by x plus 1. So minus of, so this also should be minus, it is not plus, right? So minus of x divided by x plus 1 plus minus into this plus will make this as minus, right? So plus log of x minus 1 minus log of x plus 1. So we know the nth derivative of this log of any function. Log of ax plus b is nothing but, if we take the first derivative, it will become 1 over x minus 1. So we will be able to get the nth derivative of log of x minus 1. But getting the nth derivative of this, we are going to make some trick here. So what we will do is, we have x divided by x minus 1, x divided by x plus 1 is there. So what we will do here is, we will add and subtract both this term numerator by plus 1 and minus 1. So here what I will do, I will do minus 1 and I will also do plus 1 for this first term. Similarly, I will add one term and I will negate minus 1 in these two terms. So now I can split this term. So this will become now x minus 1 divided by x minus 1 plus 1 over x minus 1, right? So what did I do? X divided by x minus 1 was there. I just add and subtracted. So if I am adding and subtracting, that is 0, so that should be fine, right? So now what happens? X minus 1 divided by x minus 1 plus, I am splitting it, 1 divided by x minus 1. Similarly, this minus sign, let me just keep it like this. So this will become x plus 1 divided by x plus 1 similarly, and this minus term is there, so minus 1 over x plus 1 here. So and whatever is remaining I will write as it is. So that is log of x minus 1 minus log of x plus 1 here. So here we can cancel x minus 1 divided by x minus 1 is there, so we can cancel this term. Same way x plus 1 divided by x plus 1 is there, so that also we can cancel. So whatever is remaining, so 1 minus 1 will become 0, so we need not write that. So 1 divided by x minus 1, so minus into this minus will make it as plus 1 over x plus 1, okay, and this will become plus log of x minus 1 minus log of x plus 1. So this is our y1. So if we observe here, now this is of the form 1 over ax plus b, both of these terms, and log of x minus 1 and log of x plus 1 is there. Even this also we know the standard function. So here already we have differentiated one, right? It is not y, it is y1. So if we have to get the nth derivative of this function x log x minus 1 minus x log x plus 1, since we have already differentiated the function y with respect to x once, so if we have to get the nth derivative, we may have to get the n minus 1th derivative from here, because once already we have differentiated here, right? And if you observe this, right, log of x minus 1 and log of x plus 1, so if we differentiate this one, the differential of the first derivative of log of x minus 1 will become 1 over x minus 1, which is nothing but this one. So if I have to take the nth derivative for this, I can write it as x minus 1, but I have to write it as d n minus 2th derivative. Here this should be the n minus 1th derivative for these two terms, but for log terms, if I have to write in x minus 1, because the derivative of log x minus 1 is 1 over x minus 1, derivative of log x plus 1 is 1 over x plus 1, so that will become in the same way, but which means that I have already differentiated these two terms one time more than these two terms, right? So if I am taking n minus 1th derivative for these two, so this will become n minus 2 derivative of the function. So now what happens, yn will be equal to, since it is nth derivative and it is y1, I have already differentiated this once, so now this will become d n minus 1 of 1 over x minus 1 plus d n minus 1 of 1 over x plus 1 plus this log function. If I have to write it in this one, means I have already I have to differentiate it. Yeah, so we have the same thing here. So nth derivative of 1 over ax plus b is nothing but minus 1 over n factorial a raised to n divided by ax plus b raised to n plus 1. So we have to take the d n minus 1th derivative for first two and n minus 2th derivative for this last two terms. So what happens? Yeah, so our yn will now become, so 1 over x minus 1, right? So now this will become minus 1 raised to n minus 1, and n factorial we have to write it as n minus 1 factorial, and here the value of a is 1, so I need not write that because 1 raised to n is 1 itself. So this I can write it as x minus 1 raised to, so here what happens, I have to take the n minus 1th derivative, right? It is not the nth derivative. So what should I have to write here is x minus 1 raised to n plus 1 minus 1, that is x power n raised to n itself. Here we were writing as n plus 1 because here it was 1 was there, right? But we have, we were taking the nth derivative. Here we are taking n minus 1 derivative, so we have to negate by 1. So n plus 1 minus 1, that will become n itself. Okay, so now here, so this term is done, plus again here minus 1 raised to n minus 1, and again n minus 1 factorial divided by x plus 1 raised to n here, and for this is the n minus 2th derivative, so this will become minus 1 raised to n minus 2 into n minus 2 factorial divided by x minus 1 raised to n minus 1, because we are taking the one more less derivative here, so this will become n minus 1 here minus 1 raised to n minus 2 factorial divided by x plus 1 raised to n minus 1. So this is our yn. So but we may have to need to show that yn will be equal to minus 1 raised to n minus 2 into n minus 2 factorial into x minus n divided by x minus 1 raised to n minus x plus n divided by x plus 1 raised to n. This is what we need to show. So let's simplify this expression. So in order to simplify this, what I will do is I will write x minus 1 raised to n terms one side and x plus 1 terms to other side. So what happens, minus 1 raised to n minus 1 factorial divided by x minus 1 raised to n, and this x minus 1 I will write this side, so this will become minus 1 raised to n minus 2 n minus 2 factorial divided by x minus 1 raised to n minus 1, and this x plus 1 terms I will write this way. So minus 1 raised to n minus 1 factorial divided by x plus 1 raised to n, and this is minus 1 raised to n minus 2 factorial divided by x plus 1 raised to n minus 1. So if we see here, n minus 1 factorial can be written as n minus 1 into n minus 2 factorial. 5 factorial can be written as 5 into 4 factorial. So n minus 1 factorial can be written as n minus 1 into n minus 2 factorial, so that we can take n minus 2 factorial outs common from these two terms. Similarly, so from these two terms we will take n minus 2 common from here, and here we have minus 1 raised to n minus 1, and here we have minus 1 raised to n minus 2, but here we will take the lowest of the term which is common. The lowest is minus 1 raised to n minus 2 factorial. If we take common from the first two terms, what will remain here? So I need minus 1 raised to n minus 1 here. Here I have minus 1 raised to n minus 2, so I have to multiply it by minus 1 raised to 1. So what happens? Minus 1 raised to n minus 2 minus 1 raised to 1, minus 2 plus 1 will become minus 1. So minus raised to 1. So and here I have to write n minus 2. N minus 1 factorial can be written as n minus 2 into n minus 1 factorial. So I have to write it here as so n minus 1. I have to write it as n minus 1. This n minus 1 into n minus 2 factorial. So this will become n minus 1 divided by x minus 1 raised to n plus I have minus 1 raised to n minus 2 I have taken outside. N minus 2 factorial also I have taken outside. So what will remain here? The whatever remaining here is x minus 1 raised to n minus 1. So that is remaining here. Same way, so here also I will take minus 1 raised to n minus 2 outside along with n minus 2 factorial. So what will remain here? So what remains here is minus 1 into n minus 1 divided by x plus 1 raised to n minus, here minus 1 raised to n minus 2 we have taken common, so this will be 1 divided by x plus 1 raised to n minus 1. Okay, so on further simplification, yeah, even the denominator also can be taken common outside here, right? So if you have x minus 1 raised to n, and here it is x minus n raised to n minus 1, right? So I can take x minus 1 raised to n minus 1 outside here, right? So what I can do here is minus 1 raised to n minus 2 into n minus 2 factorial. So from here, the lowest of the term, suppose if I have 1 by x square plus 1 by x cube, I should take x square outside. So it should be x minus 1 raised to n minus 1 if I take outside. So here it will be minus 1 is there, so minus 1 into n minus 1 will become 1 minus n, because 1 negative sign is there already. So divided by, so this will become x minus 1, because I have taken x minus n minus 1 outside. So x minus 1 raised to 1, so n minus 1 plus 1, minus 1 and plus 1 will get cancelled, and this will become 1 here in this time, because I have taken here. Same way, minus 1 raised, yeah, so let's further simplify this. So that will become minus 1 raised to n minus 2 into n minus 2 factorial divided by x minus 1 raised to n minus 1. So here 1 minus n plus x plus 1 is there. Let's multiply that side, plus x minus 1. In the denominator we will have x minus 1 here. In the same way, minus 1 raised to n minus 2 factorial divided by x plus 1 raised to n minus 1. So again 1 minus n, minus into x is minus x, minus 1 into plus 1 is minus 1 divided by x plus 1 here. So here 1 and minus 1 will get cancelled. Same way here 1 and minus 1 will get cancelled. So what will remain here is yeah, so here x minus n will be there in the numerator in the first term, and here minus of n plus x plus n will be there in the numerator of the second term. But if you observe the denominator, it is x minus 1 raised to n minus 1 into x minus 1. So x minus 1 raised to 1, the meaning of this is x minus 1 raised to 1. Here it is x plus 1 raised to 1. So a raised to m into a raised to n is a raised to m plus n. So I can multiply this together, n minus 1 plus 1. So here what happens, this will be minus 1 raised to n minus 2 into n minus 2 factorial divided by, this will become x minus 1 raised to n minus 1 plus 1, this will become n, this into this will become x minus n. So plus again this one minus 1 raised to n minus 2 into n minus 2 factorial divided by x plus 1 raised to n minus 1, sorry, not n minus 1, already n minus 1 into x plus 1 raised to 1 is there, so this will become x plus 1 raised to n. So what will remain here, so minus n minus x, so minus n I will take outside, so this will become x plus n. So if we see here, we have minus 1 raised to n minus 2 divided by x minus 1 raised to minus 1 raised to n minus 2 into n minus 2 factorial common in both the terms. So what I will do, I will take minus 1 raised to n minus 2 into n minus 2 common from both the terms. So here x minus n divided by x minus 1 raised to n. Here we have minus sign, so I will take the minus sign this side. So this will become x plus n divided by x plus 1 raised to n. So this is the required proof that they wanted to show. Yeah, thank you for watching, and let me know if you have any questions. I will see in the next video. Thank you all. Bye.